Hello everyone. Today we'll be solving AQA GCSE Chemistry Foundation Tier Paper 1, and today we are solving May 2018. Let's see the first question. This question is about mixtures. Substances are separated from a mixture using different methods. Draw one line from each substances and mixture to the best method of separation. So what we see here? We see substances and mixture. So the first substance and mixture that we can see here is ethanol. From ethanol and water. Guys, ethanol is an alcohol and has a boiling point of 78 degrees Celsius, and water has a boiling point of 100 degrees Celsius. So they have a boiling point difference, and these two liquids, they can mix together. So they are miscible liquid. They are miscible liquid. When we want to separate miscible liquid that mixes together but has a different boiling point, we can use the process fractional distillation. So fractional distillation will be our process. The next thing that we need to separate is we need to separate the salt from the seawater. Since we are going to separate the salt from the seawater and we don't need the seawater, so definitely we can take the help of evaporation. Once we evaporate the water out, we are gonna be left with the salt. So in this case, we can take the help of crystallization. Crystallization is a process where basically water is evaporated from the liquid and the salt is left behind. The different colors in black ink. Now we know that black ink is a mixture of colors. All right, these colors mixes together and they can be separated by using a particular process called chromatography. So we can use chromatography, all right, and by that they will be separated. Two, a student filters a mixture. Figure 1 shows the apparatus. Figure 1, beaker. We can see in the beaker there is a mixture, okay, and we can see there is a filter paper cone and there is a flask. Suggest one improvement to the apparatus. So how can we improve? If we notice carefully, we haven't included any filter funnel in this particular experiment. So we can add a filter funnel in this experiment. So adding a filter funnel will be the improvement. Complete the sentences. Choose answers from the box. Okay. We see there is condensation, condense, evaporate, freeze, melt, solidify. So basically, these are the name of some of the processes. In simple distillation, the mixture is heated to make the liquid. So when we heat a particular mixture, the liquid is going to definitely evaporate. So the liquid evaporates. All right, the vapor is then cooled to make it. So when we cool down the vapor will condense. So it will condense. Great. The next question, figure 2 shows the arrangement of atoms in pure metal and in a mixture of metals. So here we can see figure 2. Pure metal. What is pure metal? Pure metal is metal A. All right, so we can see there is a regular structure, and in the mixture of metals there is metal A and metal B. As you can see, metal B has a larger particle size and thereby distorts the structure of metal A. All right, the irregular structure of metal A, and thereby if we were to push this particular alloy, it would be harder to push. All right, so it would be a much harder alloy than the pure metal. Calculate the percentage of metal B atoms in the mixture of the metals shown in figure 2. So to do this, basically what we need to do is we need to count all of the atoms. So 3, 5, 10, another 5, 15. So there is a total of 20 atoms. So 20, and metal B we have 2 atoms times 100%. So our answer will be 10%. So percentage of metal B atoms are 10%. What is a mixture of metals called? A mixture of metal is called an alloy. All right, it's a pretty simple, straightforward answer. All right, whenever we have two metals mixing together, they do not form a compound. All right, they rather form a mixture, which is known as an alloy. By the way, metals can be also mixed with non-metals to form alloys, so that part we need to take a note of. Why is the mixture of metals in figure 2 harder than the pure metal? All right, so as you can see in the metal 2, in the second part of it, we have a mixture of metals, and the larger metal B atoms is going to prevent the smaller layers of metal A from sliding, so thereby it will make it harder. So we can say the answer can be, let's see the options. The atoms in the mixture are different shapes. They are different shapes, but that doesn't explain why it's gonna be harder. The layers in the mixture are distorted. Yes, this is the main reason. The layers are distorted, so they cannot slide past each other. So that's why that makes it harder. A nanoparticle of pure metal A is a cube. Each side of the cube has a length of 20 nanometer. Figure 3 shows the cube. So there is a length of 20 nanometer by 20 nanometer by 20 nanometer. All right, now the question says, what is the volume of the nanoparticle? So we know that to calculate the volume, we need to multiply length into breadth into, or we can say length into width into height, or whatever you say, length into breadth into height, length into width into height, same thing. So we multiply 20 times 20 times 20, which will give us 8 with 3 zeros. So thereby 8,000 nanometer cube should be the answer. Guys, we're moving to question number 2. The halogens are elements in group 7. Bromine is in group 7. Give the number of electrons in the outer shell of bromine atom. Okay, very good. Any element that belongs to group 7, meaning they have 7 electrons in their outer shell. So this will be group 7. So the answer will just be 7. Bromine reacts with hydrogen. The gas hydrogen bromide is produced. What is the structure of hydrogen bromide? So, okay, hydrogen bromide, let's see. Hydrogen has only 1 electron in the outer shell. And bromine, on the other hand, has 7 electrons in the outer shell, shown by the dot and cross structure. So if the hydrogen were to share electrons with the bromine, it would share like this, preferably, to fulfill the octet state. So definitely it would be a small molecule. All right, so the answer will be small molecule. Guys, the next question is, what is the formula for fluorine gas? Very good question. Fluorine, if we check in the periodic table, fluorine belongs to group 7. All right, as discussed earlier, any element that belongs to group 7 has 7 electrons in their outer shell. So here I represent 7 electrons with the dot diagram. And I'm drawing another fluorine, different color. That doesn't mean that it's different fluorine. All right, it's the same fluorine. All right, it's just that I want to show that that dot and cross diagram clearly. All right, okay, here if they share the electron, all right, between them, that makes it a diatomic molecule, meaning F2. All right, so this will be wrong, this will be wrong. Okay, F2, this is the correct answer, guys. So fluorine, since it is diatomic, all right, it shares 1 electron between each other, and that makes it F2. F to the power of 2 or 2F, all of them will be wrong. A student mixes solution of halogens with solutions of their salts. Table 1 shows the student's observation. All right, we can see there is a chlorine, which is a colorless gas, bromine, which is orange, and iodine, which is brown. Okay, now when we react the chlorine with potassium chloride, all right, obviously chlorine is not going to react with chloride, no visible observation will be there. When it reacts with potassium bromide, the chlorine displaces the bromide and releases the bromine. The solution turns orange because of the bromine. All right, When the chlorine is reacted with iodide, the chlorine displaces the iodide and makes it into iodine. So solution turns brown. Very good. So in both of these cases, we saw that there is a reaction happening. All right. And in the case of bromine, we see only reaction happening in the case of the iodide. With chloride, there was no reaction. And with iodine, there was no change in chloride and bromide. So the question says, explain how the reactivity of the halogen changes going down the group. So going down the group, we go from chlorine to bromine to iodine. As you can see, chlorine is the most reactive because it could displace both bromide and iodide. However, bromine was only capable of displacing iodide. That means bromine cannot displace chloride, means it's not stronger than chloride. Okay, so in terms of reactivity, it is less reactive than chlorine. Okay, so our answer should be written in a chronological manner, all right, according to what we have understood from this particular observation. So the first thing that we're going to conclude is the reactivity decreases down the group 7. The reactivity decreases down group 7. Okay. Because the chlorine is able to displace, as we have discussed, both the bromide and the iodide. Guys, since we have 3 marks here, I'm going to change colors which will indicate each marking point. Because chlorine displaces bromide and iodide, so it's the most reactive of the 3. And bromine displaces iodide or iodine. All right, so all right, and finally what we can say, the iodine does not react, and the iodine does not react, which puts them in a reactivity order of chlorine first and then bromine and then iodine. Guys, moving to next question. A company uses chlorine to produce titanium chloride from titanium dioxide. What is the relative formula mass MR of titanium dioxide TiO2? All right, in a question like this, guys, when we have to find relative formula mass MR TiO2, we have to consider the relative formula mass of titanium, which is 48, and then add it with, because there are 2 oxygens. Okay, guys, we can see that there are 2 oxygens here, so we're going to multiply 2 times 16, and then we're going to add the total, so our total comes to be 80. The company calculates that 500 grams of titanium dioxide could produce 1.2 kilograms of titanium chloride. However, the company finds that 500 grams of titanium dioxide only produces 900 grams of titanium chloride. Okay. So the thing is, in calculation, we see that 500 grams of titanium dioxide was supposed to produce 1.2 kilogram, or let's say 1200 grams of titanium chloride. It was supposed to produce. All right. This is like just calculation. all right, in the notebook. All right, it's just a calculation in the notebook says that if you have 500 grams of titanium dioxide, all right, you're gonna get 1200 grams of titanium chloride. However, in practice, what the company finds out that if they have 500 grams of titanium dioxide, they can only get 900 grams of titanium chloride, which can be mostly due to impurities. This titanium dioxide can have many impurities, like it can have, like, sand in it, like silicon dioxide, which will not react. And also we need to understand that this titanium dioxide, all right, can have moisture in it, all right, which is like, just a unnecessary mass when we are calculating its mass. All right, so in reality what we're going to get is we're not going to get that same amount of product that we're supposed to get, because this is calculation, and calculation assumes that everything is 100% pure. But in real life nothing is ever 100% pure. So we need to find out the percentage yield. In case of percentage yield, we can write, remember, percentage yield is, all right, what we have received, all right, what we received in real life. So which is, we received 900 grams in real life. We are supposed to receive 1200 grams. We didn't receive that. All right, so we're going to put that one at the bottom. All right, and we are going to multiply it by 100%. So when we do that, we find out that our percentage yield of this particular process is 75%, which is, in industry standard, is a very good percentage, by the way. All right, because in real life we really have to deal with a lot of impurities. All right, chemicals found in school laboratories can often be very, very pure and can result in very small percentage yield error. However, chemicals found in real life, all right, often are not of that high quality and often contains a lot of impurities, which has to be discarded, and thereby the percentage yield decreases. This question is about the structure of the atom. Complete the sentences. Choose answer from the box. Each word may be used once, more than once, or not at all. Okay, good. So what do we have here? We have electron, ion, neutron, nucleus, proton. The center of the atom is the, okay, so obviously the center of the atom will be nucleus. The two types of particle in the center of the atoms are protons and the neutrons. So protons and neutrons, they are in the center of the atom. They contain the most amount of mass. James Chadwick proved the existence of the, so basically James Chadwick, all right, he was responsible for proving the existence of the neutron. Niels Bohr suggested particles orbit the center of the atom. This type of particle is the electron. We know that electron orbits the center of the atom, just like the way the planets would orbit the sun. The electrons orbit the nucleus. The two types of particle with the same mass are the neutron and obviously the proton. Protons and neutrons, they have similar mass. Okay, almost similar, even though proton is a little bit lighter. All right. Table 2 shows the information about two isotopes of element X. You can see isotope number 1 with a mass number of 63, percentage abundance 70, isotope 2 65, 30. Okay. In order to calculate the relative atomic mass, or we can say average relative atomic mass of that particular element, all right, actually relative atomic mass is average always. We have to multiply mass number with the percentage of the isotope 1, mass number with percentage of isotope 2, all right, and then we need to divide everything by 100. All right, give your answer to one decimal place. Guys, in a question like this, we have to be very careful mentioning our answer to one decimal place, because here 3 significant figure does not matter. All right, so our mass number, the first isotope is 63, and we have it available at 70%. We're going to add it to 65. The next one is available at 30%. Let's just confirm that. Okay guys, we are confirmed. Okay, divided by 100, and in that case the answer comes 63.6. So the relative atomic mass, or the AR, of this particular isotope is 63.6. all right, so that makes it to one decimal place, guys. This is the one decimal place answer. After decimal, we're just allowed to put only one digit. In this case, when it says one decimal place, if it says two decimal place, then after the decimal we're allowed to put two digits. All right, guys, now let's move to the next question. Suggest the identity of the element X. Use the periodic table. Element X is, okay, so in order to find out the element X, we can go to the periodic table and find whatever is the nearest mass, all right, for the AR, all right, which is the closest one in the periodic table. You just, whenever you're going to give an exam, you're going to have a periodic table handy, obviously, all right. They're going to provide it to you. So all you need to do is you need to just find it out, which mass is just the closest one. In this case, the copper element, the element copper, is close to 63.6, which is the element copper actually has a mass of 64.5, sorry, 63.5, I believe. All right, so this is 63.6, so it's very close. The radius of an atom of element X is 1.2 into 10 to the power of minus 10 meters. The radius of the center of the atom is 1 divided by 10,000, the radius of the atom. Okay. Calculate the radius of the center of the atom of element X. Give your answer in standard form. So the radius of an atom is this one, and the radius of the center of the atom is 1 divided by 10,000, the radius of the atom. All right, so in order to do this particular calculation, what we need to do is we need to find out the radius of the atom of element X. Okay, so we have that information here, which is 1.2 into 10 to the power of minus 10. All right, this is given in meters. Okay, now the radius of the center of the atom, we'll have to divide it by 1 over 10,000. Actually, if we divide it by then we just divide it by 10,000, or we can just multiply 1 over 10,000. Okay, 1 over 10,000 means the answer, whatever the 1.2 10 to the power minus 10 divided by 10,000. Okay, so when we do that, our answer becomes 1.2 into 10 to the power of minus 14. Okay, so because we were dividing unit that was in meters, so when we divided by 10,000, we just still get the unit in meters. So 1.2 into 10 to the power of minus 14. A student investigated the electrolysis of sodium chloride solution. Figure 4 shows the apparatus. Okay, all right, we see the apparatus, figure 4. We see chlorine, we see volume measuring cylinder, okay, measuring cylinders, inverted measuring cylinders. We see hydrogen, sodium chloride solution, we see graphite electrodes. All right, that is in work. We have DC power supply for the electrolysis. The student measured the volume of gas collected at each measuring cylinder every minute for 20 minutes. So for 20 minutes the student keeps on measuring. Okay, figure 5 shows the volume of hydrogen gas collected in the measuring cylinder after 8 minutes. Okay, so after 8 minutes, if we read, because we're reading from the we're reading from this direction, all right, so we will measure this 3. This will be 3.1, 3.2, 3.3, 3.4, 3.5, so 3.6. We can see our reading to be 3.6. Okay, so, all right, so 3.6, the unit measurement is given in cm cube. The question says, what is the volume of hydrogen gas collected? Definitely the volume will be 3.6 cm cube. Figure 6 shows the results of the investigation. We can see the figure 6. We can see the volume of chlorine, we can see the volume of hydrogen. The volume of chlorine is less than the volume of hydrogen. All right, okay, which one of the lines in figure 6 shows the volume of gas collected is directly proportional to the time? Guys, Whenever a particular relationship is directly proportional, it must go straight through the origin. So in this case, we can see the line for hydrogen only. Which of the lines on figure 6 shows a positive correlation between the volume of gas collected and time? Okay, so we see positive correlation. What does positive correlation mean? First, we need to understand. When the time is increasing, all right, we can see that the volume of hydrogen is also increasing. Okay, so this will refer to as positive correlation. Now, if you notice carefully, even though chlorine is not increasing in the beginning so fast, but it's still increasing with time. All right, so both of them are showing positive correlation. So our answer will be both lines. Next question. A teacher demonstrates the electrolysis of different substances using graphite electrodes. All right, oftentimes in school laboratory we will use graphite electrodes because they are inert, meaning they're unreactive, and they're very inexpensive. Okay, they're good conductor of electricity, so it's very readily available for school laboratories. Figure 7 shows the apparatus used. What is figure 7? Okay, let's see. We can see the graphite electrodes, we can see substances tested. All right, we see the beaker, DC power supply, all right, with positive and negative terminals. Why can graphite conduct electricity? Okay, that's a very good question. Guys, graphite can conduct electricity because they have delocalized electrons. All right, remember, in like all of the structures that conduct electricity, they should have free electrons or delocalized electrons. So graphite has delocalized electrons. This will be the correct answer. Graphite exists as a layer of atom. Only existing as a layer of atom does not give any element ability to conduct electricity. Graphite has giant structure. Even diamond is a giant structure, but it doesn't conduct electricity because there is no free electrons. Graphite has a high melting point. Many elements, for example, silicon dioxide, which is sand, or you can consider like glass, all right, it has very high melting point, but it's still high melting point is not associated with electrical conductivity. Only delocalized electrons is associated with electrical conductivity. So whenever you see the word delocalized electron, go for it. All right, that's the answer. The question number 4.5. Teacher demonstrates the electrolysis of molten zinc chloride, potassium bromide solution. Complete the table 3 to predict the product. Calculate the answers from the box. Okay, when we have molten zinc chloride, remember, when it is molten, the only positive ion available here is Zn2 plus. If you don't know the charge, guys, don't worry. All right, no need to worry about that. You can at least guess that there is zinc ion. Okay, and the negative ion that is present is chloride. So since there is only one positive ion present, which is zinc Zn2 plus, the product at the cathode or the negative electrode, the zinc will gain electron and produce zinc, definitely. So it's very simple and straightforward. And for the chloride, it's gonna go to the anode because it's negative. All right, negative means anion is going to go to the positive electrode because unlike charges attract, all right, and like charges repel. So we're gonna get chlorine here. All right, next, potassium bromide solution. In potassium bromide, what do we have? In potassium bromide, the negative electrode is going to have okay, now, okay, there is, sorry, my bad, there is a problem in this one. Because it says that it is a potassium bromide solution, then we have the potassium ion, we also have the bromide ion. However, since this is a solution, there is also water, and water brings in some extra ions, which is the hydrogen ion and the hydroxide ion. All right, so we need to consider them as well. Okay, now guys, when it comes to potassium ion and hydrogen, we need to understand that they have a competition in terms of their reactivity. We know that potassium is more reactive and hydrogen is less reactive. So the product at the cathode will be hydrogen instead of potassium. All right, so the product will be hydrogen. And between bromide and hydroxide, the competition, all right, The bromide wins because it is less reactive compared to that of a hydroxide. So bromine will be the answer. Question number 5. A student investigated the mass of copper oxide produced by heating copper carbonate. This is the method used. Weigh an empty test tube. Okay. Weigh 2 grams of copper carbonate into the test tube. Heat the copper carbonate until it appears to be having no further change. Good. Reweigh the test tube and the copper oxide produced. Subtract the mass of empty tube to find the mass of copper oxide. Repeat steps 1 to 5 twice. Alright, repeat steps 1 to 6 with different masses of copper carbonate. Alright, table 4 shows the student's result. Okay, so when the mass of the copper carbonate is 2 grams, trial 1, 1.29, 1.27, 1.31, 1.29 is the average. Okay, guys, this shows a pretty relatively nice answer. Alright, so what we can consider in this one is that they are just averaging this particular values out. Okay, so let's see. Okay, there is a x here, we can see. That means they will be asking us to find out the x. Okay, let's continue with the question and let's see what happens. The equation for the reaction is copper carbonate turning into copper oxide and producing CO2. So CO2 gas is going to escape, which is why the mass is decreasing. Complete the sentence. The state symbol shows carbon dioxide is a, okay, so we know the carbon dioxide is a gas, so the state symbol, all right, G represents it's a gas. Remember guys, S represents solid. All right, just a recap. AQ, yeah, my handwriting is very bad, but anyways, AQ represents aqueous. All right, I believe the spelling is AQUEOUS. Yeah, if I'm wrong, guys, correct me. All right, and L represents liquid. So if you have H2O, actually we'll have to refer it to as liquid. We cannot refer it to as aqueous, even though, yeah, like water is the basis of something becoming aqueous. Though something dissolves in water, we say aqueous. All right, guys, let's move on. Question number 5.2. Why do the contents of the test tube lose mass in the investigation? So basically, as we have already discussed earlier, the gas escapes. So the gas has mass, and that's why the mass decreases. 5.3. Calculate the mean mass of X in table 4. Mean mass. All right, okay, so in table 4, okay, that's nice. Let's see. Oh, guys, let's see the value. All right, okay, so what do we have here? We have 5.12, 5.15, and 5.09. All right, so we can add these three. 5.12, 5.09, the last one, and 5.15. Then we divide it by 3 because we have 3 sets of values. So the answer comes 5.12. All right, 5.12. Guys, here it is written G. This G refers to gram. One of the results in table 4 is anomalous. Which result is anomalous? Okay. Now guys, when they say that something is anomalous basically refers that something that does not match the trend. It's like off the trend. So let's see, anything that doesn't match the trend, it must have like a really big value, all right, which doesn't match the original, all of the other values. So guys, if you notice carefully in this one, the second line, 2.89, 2.57, 2.59, and 2.58 is the average. That means this value was neglected because probably, it didn't lose enough amount of mass in this one, all right, to justify the answer. All right, so yes, in mass of copper carbonate, which has 4 grams, trial 1, we have a error. All right, so mass of copper carbonate 4 gram and trial 1. Okay, guys, moving on. Suggest how the student in the investigation could be improved to make sure the reaction is complete. So guys, In the experiment, it says that repeat steps 1 to 5 twice. All right. So if we reheat the test tube to ensure all the CO2 have escaped, and then take the mass again, and we see that the mass didn't decrease. If the mass keeps on decreasing, then we keep on repeating the process. All right. So the way we ensure that all of the CO2 has escaped is we will reheat that particular, we will reheat. Okay. And once we reheat, all right, and we will reweigh until, so reheat and then reweighed until we reach a constant mass. Alright guys, now moving into the next question. Another student repeated the investigation using magnesium carbonate instead of copper carbonate. The word equation for the reaction is magnesium carbonate, magnesium oxide, carbon dioxide. Okay, great. So let's see the question one more time. Another student repeated the investigation, but instead of using copper carbonate, the student has used magnesium carbonate. Okay. And the reaction is just as same as that of copper carbonate though. So we need, the question says, figure 8 shows the results of the investigation. Okay, we can see that as the mass of the magnesium carbonate increased, all right, the mass of magnesium oxide in grams also increased. Okay, draw a line of best fit on figure 8. Line of best fit. Oh, okay. I guess we did it already, but let's do it again. So we can start from 0. When the mass is 0, the mass of magnesium oxide will also be 0. And okay, we have a pretty much straight line. Yeah, make sure to touch all the points. Next question. Determine the mass of magnesium oxide produced by 8.4 grams of magnesium carbonate. In situations like this, guys, it's best to do extrapolation. Extrapolation is basically you find out that this is 9, so obviously this must be 8.4. So at 8.4 you are going to draw a straight line which is going to touch our other line. Okay, and then from that particular point we are going to draw another straight line which is going to touch this line. So now we're going to count this one. So this is 3.5, 6, 7, 8, 3.8. So guys, the mass will be 3.8. Guys, in these cases, do not be worried about your correct answer because it's always based on your graph. If you have drawn a wrong graph, or like my one, which is not really that correct, you will lose mark for that graph, but not for the extrapolation though. So extrapolation will always be correct as long as you do the process correct. All right. Calculate the mass of magnesium oxide produced when 168 grams of magnesium carbonate is heated. Okay. So to find out the mass, all right, like this, it will be mass equals to 168 times. Okay, guys, now this is what we are going to find out of. But previously we know that if we had 8.4 gram, we got 3.8 grams. Okay, so we're going to divide it by 8.4 and multiply it by 3.8. Guys, I'm again telling you, we got 3.8 grams of magnesium oxide when we used 8.4 grams. And since now we want to find out for 168 grams, so we're going to divide the 168 by 8.4, which is technically meant by this 1 over 8.4, and then because our previous result for 8.4 gram was 3.8, so if we multiply that particular 3.8 with the answer that we're going to receive from this division, we're going to have, so the answer comes 75.99, so we can make it equivalent to 76 grams. If they already tell us that we have to give the answer to 1 decimal place, we must give it to 1 decimal place, but if they don't, then we can just round it up to a whole number, if that is convenient. Question number 6. A student investigated the temperature change in displacement reaction between metals and copper sulfate solution. So different metals are being used. Those metals are going to displace the copper from its solution. So once they displace the metal from its solution, basically heat will be generated. All right. This is the method used. Point number 1, measure 50 cm cube of copper sulfate solution into a polystyrene cup. Record the starting temperature of the copper sulfate solution and add the metal and start the solution. Record the highest temperature the mixture reaches. Calculate the temperature increase for the reaction. Repeat steps 1 to 5 with different metals. So basically what's happening here is that once we are going to add different metal with this particular solution, all right, we are going to experience a chemical reaction, and this is a displacement chemical reaction. The copper 2 ion will be displaced by the ion that we are replacing with the metal that we are adding. If the displacement reaction is successful, then this will generate some amount of heat energy, which then can be calculated. Now the question says, question number 6.1, draw one line from each type of variable to the name of the variable in the investigation. The type of variable. So the variables are of two types. One is dependent variable and one is independent variable. So independent variable are the ones that we can choose. So obviously we are choosing what type of metal to be adding, that we are going to add to the copper sulfur solution. So definitely the type of metal will be the independent variable, and dependent variable is usually the result. So the result is the temperature change. Whatever the temperature change that's going to occur, we cannot predetermine that. We are finding it as a result. So dependent variable are the results. Question number 6.2, the student used a polystyrene cup and not a glass beaker. Why did this make the investigation more accurate? We know that polystyrene cup are they have a very high insulating properties. They are highly insulating. So since they can insulate a lot, all right, so definitely the polystyrene cup is a better option than the glass beaker. The glass by itself, the material, will absorb a lot of heat, which will then make the experiment a little bit inaccurate. Okay, so tick one box. Glass is breakable. All right, so this is not the reason. Glass is transparent, also not the reason for, we need insulation. Polystyrene is a better insulator. Definitely polystyrene is a better insulator. Question table 5 shows the student's result. Magnesium, so when the student added magnesium, temperature change 38, nickel 8, zinc 16. The higher the temperature change indicates the more reactive the metal, all right, compared to that of the copper 2 plus ion in the copper solution. So 38 degrees Celsius indicate the magnesium being the most reactive. This is the most reactive, this is the second most reactive, and this is the least reactive. So complete figure 9 use data from table 5. Okay, so 38 degrees Celsius has been already labeled for us. All right, so for nickel is 8. So we can just follow the same rule. We can use 2 boxes from both sides. We are leaving 2 boxes, and it went up to a temperature of 8 degrees Celsius. So 8 degrees Celsius will be, this is 5, this is 6, 7, 8. So we are gonna label it up until here. All right, that was very easy. All right, so this was nickel. So NiCkel, nickel. All right, okay, then we have zinc. Zinc, we have 16 degrees Celsius. So the rule goes the same, 2 boxes from 2 sides, we're leaving it. All right, and 16 degrees Celsius, this is 15, this is 16. So we can draw a line here. All right, and we're gonna draw a straight line here. Okay, and all right, so this is zinc. Okay, next 6.4, the student concluded that the reaction between the metal and the copper sulfate solution are endothermic. Give one reason why the conclusion is not correct. You see, endothermic is a reaction in which temperature is absorbed from the surrounding, but this reaction, they have increased the temperature of the water. So in all cases, this reaction is exothermic, meaning the heat is given out. All right. So the answer will be exothermic. That's why the student is not correct. All right. So we will say temperature increases in all reaction. All right. Temperature increases. All right. Or we can say temperature does not decrease, which is the same point. 6.5, the temperature increase depends on the reactivity of the metal. Write the metal, magnesium, nickel and zinc in order of reactivity, most reactive. So we can conclude from this particular experiment, the higher the temperature change, so most temperature change in magnesium, and then zinc, and so first we are going to say magnesium, then we're going to write zinc, and then we're going to write nickel, because the higher the temperature change means the most reactive it is. Y is a unknown metal. Describe a method to find the position of Y in the reactivity series of in question 6.5. Okay, so basically in a question like this where they are asking you, we just have to mention a suitable method how we are going to find out. So all right, what we can do is, all right, we can react the unknown metal Y with copper sulfate solution. All right, so we'll say unknown metal Y, unknown metal Y can be reacted with copper sulfate solution. Sulfate solution. All right, the temperature change is recorded. The temperature change is recorded. Once the temperature change is recorded, all right, the del T or temperature change, del T or temperature change, the magnitude of the temperature change, all right, value will indicate its relative position in the reactivity series. Value will indicate its relative position in reactivity. Guys, why did we write this particular answer in this way? The reason why we wrote this particular answer in this way, because they said that we need to describe a method. We will only write the method. All right, in practical, these are the things that we want to record, and that's how we will be able to conclude. So in our answer, we're just going to write the approach that we could have taken, all right, to be able to find this. Now many student gets the particular hint when they read this kind of question, is that they need to describe and they need to state where that particular metal Y lies and everything. We do not need that. All right, we just need to write the process, how we are going to reach to the conclusion of the relative reactivity of the particular metal. Figure 10 shows the reaction profile for the reaction between zinc and copper sulfate solution. Okay, so we can see the reaction between zinc and copper sulfate. All right, we can see A, B, C, D. All right, okay, so A representing reactant, C representing activation energy, all right, B representing del H or enthalpy change, and D representing product. All right, and E representing is the total energy released from the portion where the reactant got activated to the portion where they have turned into product. Okay, which letter represents the products of the reaction? So the product is represented by D. We give a tick mark in D. All right, which letter represents the activation energy? The activation energy is represented by C. So the next is question number 7. This question is about elements in group 1. A teacher burns sodium in oxygen. Complete the word equation for the reaction sodium plus oxygen. Guys, when sodium reacts with oxygen, any metal reacting with oxygen will produce metal oxide. So sodium reacting with oxygen, we will just simply write sodium oxide. What is the name of this type of reaction? The type of reaction is oxidation because we are adding oxygen to it. All right, question number 7.3. Teacher dissolves the product of the reaction in water, adds universal indicator. Because sodium oxide is alkaline, the universal indicator turns purple, indicating that this is alkaline. All right, remember, alkaline from 0 to up until 7. From that range is acidic. 7 is neutral, and 7 to 14, all right, that particular portion is basic or alkaline. This is basic or alkaline, all right, and this particular portion is acidic. All right, and 7, the exact point of 7 is neutral. Okay, so what is the pH of the solution? So it cannot be 1, it cannot be 4, 7 is neutral, so it can only be 13. The solution contains a substance with the formula sodium hydroxide. Give the name of the substance. So guys, this is sodium and this is hydroxide, so the name will be sodium hydroxide. All alkalis contain the same ion. What is the formula of this ion? Guys, we know that all alkalis will contain hydroxide ion. Acid contains hydrogen ion, all right, and all alkali must contain hydroxide ion. Solution of sodium hydroxide had a concentration of 40 gram per dm cube. What mass of sodium hydroxide would be therefore be in 250 cm cube of the solution? In a question like this, first of all, we need to determine what does 250 cm cube equates up to in dm cube. So volume in dm cube, and then we can divide the 250 cm cube with 1000 cm cube per dm cube, which will give us a result of 0.25 dm cube. So now we know that we actually require not 1 dm cube but rather 0.25 dm cube. Now if we want to know the mass, all right, mass of NaOH, what we can simply do is we can multiply 0.25 dm cube with 40 gram per dm cube, with 40 gram per dm cube. So when we do 40 gram per dm cube, the per dm cube cancels out with each other. We are left with gram. 0.25 multiplied by 40 is equals to 10. So 10 gram. All right, so the mass of the sodium hydroxide needed will be 10 gram. Guys, moving to question number 7.7. The melting point of the element in group 1 show a trend. Table 6 shows the atomic number and melting point of group 1 elements. Okay, lithium, atomic number 3, melting point in degrees Celsius 181, sodium 11, or atomic number 11, 98, potassium 19, 63, 37. Guys, as we can see, the trend is decreasing down the group. So definitely we can assume that for 37 it's gonna be less for rubidium. Now plot the data in table 6 on figure 11. Okay, so if we plot this particular data, all right, so let's see. For first one we had lithium 181. All right, so lithium with the atomic number of 3, 181. So we can see atomic number 3 is here. Okay, so let's write down the 3, and it's 181. So 180, and this is 200. That means each box is representing 2. So 181 will be here in the middle of this. We can do two things, guys. We can either make a cross half of each of the boxes, or we can give a dot with a circle that reaches half of each of the boxes. So both of them will be a proper method of doing it. So the next one will be 11 and the temperature is 98. So 11 will be definitely here. This is 11. All right, and the temperature is 98, which is 80, 90. All right, and this will be 98. We can draw the cross in this way, half of each of the boxes, or we can put it and then put a circle. So yeah, I've shown you both of the methods. So anyways, the next is 19 for potassium. Potassium is 19, so potassium will be here. Okay, potassium 19, temperature is 63. As we can see, as the proton number is increasing, the temperature is exponentially decreasing. All right, 19. Next, 37. All right, that value is not given, so we're gonna move to the next one, which is 55 and 29. 55, 50, 50. This is 60, 55, and 29. So 20. All right. This is 30. So in between this is 29. All right. So this is 29. Okay. Now the question is predict the melting point of rubidium atomic number 37. Since they have given us information in graph and then we are doing the graph, so it will be a better choice that we connect these particular points first and then we estimate. So technically, if the graph were to reach this particular point, then we would have a line like this. All right, and in the case of 37, so let's extrapolate. Guys, remember that your extrapolation will be checked with your graph. You will be never judged from a original graph, a graph that has been drawn by the teacher or the exam board. So something like that, I shouldn't be saying original, like a computerized model graph or something. It's like it's just the student's graph that is checked. All right, so just keep that in mind. Don't be scared if your handwriting is not that good, if your graph is not that good. Don't worry that much. It's just normal. We're humans, we make mistakes. Some of our handwriting are not the best, like mine. Okay, soluble salts are formed by reacting metal oxides with acid. So this is question number 8.1 states that give one other type of substance that can react with an acid to form a soluble salt. So to make a soluble salt, all right, we can react a particular acid with a metal, or we could react it with metal hydroxide, which is basically alkali or a base. Guys, the difference between base and alkali is that the alkalis are soluble, bases are insoluble. All right, and even alkalis can be called bases, but the thing is, only the base that dissolves in water that can be called alkali. You get the point. So metal hydroxide, we can react metal carbonate, we can react, all right, metal carbonate. Now some of you might be wondering that what if I write alkali? Yeah, definitely you are correct. If you write alkali, you're correct. Any one of these answers, just guys choose one and write. You cannot write multiple answer in your exam, so just write one. Calcium nitrate contains Ca2 plus and NO3 minus. Give the formula of the calcium nitrate. So when writing formula, remember there is 2 plus here and there is only 1 minus here. Okay, so they need to exchange numbers. The 2 will go to the nitrate side and the 1 will come to the calcium side. So it's going to be Ca, and because nitrate is like 4 atoms together, like 1 nitrogen, 3 oxygen, so you just put CaNO3 2. Describe a method to make pure dry crystals of magnesium sulfate from metal oxide and dilute acid. So guys, obviously we need to use magnesium oxide and sulfuric acid, okay, because we are going to use metal oxide and we're going to make magnesium sulfate. So all right, magnesium oxide and sulfuric acid. is reacted together in a beaker. Guys, I'm changing color to indicate numbering, the point, or which point is giving how many marks, to indicate that. However, we may need to write more than 6 marking point to achieve a level 3 answer. So keep that in mind. Okay. Magnesium oxide and sulfuric acid is reacted in a beaker. All right. Next. All right. The reactants are warmed. The reactants are warmed. Okay. And the reactants are warmed to ensure complete complete reaction. And magnesium oxide is added in excess. You see, magnesium oxide is not soluble in water. So if we add in excess, it will ensure all the acid is reacted. Okay. Magnesium oxide is added in excess to ensure complete reaction, to ensure all acid is reacted. All acid is reacted. All right. With continuous stirring. All right, guys, stirring is needed, guys, because you want to make sure that all of them are they're mixing properly, they're reacting properly. Okay, the solution is filtered using filter paper and funnel to remove excess magnesium oxide. The solution is filtered using filter paper and funnel. All right, to remove the excess magnesium oxide. To remove the excess magnesium oxide. The solution is then heated in an evaporating basin. Until crystallization point. Until crystallization point. The solution is then left to crystallize. All right, the crystals are then filtered. Crystals are then filtered and dried in a filter paper. We can also use a paper towel. So guys, that's basically it, okay, for the entire process. All right, if we write an answer, the one that we have written in this particular for this particular question, if we write an answer like this, it's definitely going to get the full marks. There's no question into it. Writing less would also give you full marks. However, guys, please remember that we need to write until the end of the process. All right, we need to mention the entirety of the process. That's what is important as well. You answer it correctly. Okay, you need to mention the full process, otherwise getting the full mark is a little bit difficult. This question is about metals and metal compounds. Iron pyrites is an ionic compound. Figure 12 shows the structure of iron pyrite. So this is iron, the atoms of iron and the sulfur. Determine the formula of iron pyrites. Okay, guys, good question. We can see for each iron there are 2 sulfurs. So the formula should be FeS2. This is how you determine formula from the model that is shown. An atom of iron is represented with 56 Fe. So basically 56, all right, proton number 26, all right, and iron. So we can definitely say what is the number of protons. The number of protons 26, number of neutrons 56 minus 26, which is equals to 30. Number of electrons will be always equal to the number of protons in an atom. Some say neutral atom. Guys, the thing is, if an atom An atom can only be an atom if it is neutral. Otherwise, it's an ion. Iron is a transition metal. Sodium is a group 1 metal. Give two differences between the properties of iron and sodium. So basically, iron has a higher melting point. All right. Iron is denser. Iron is stronger, obviously. Iron can be used as a catalyst compared to that of sodium. So since we are, we have to give two differences between the properties of iron and sodium. So we're gonna mention for the iron. Okay, iron has higher melting point. Iron has higher melting point. Guys, iron has a melting point of around 1000 degrees Celsius, and sodium melts at 89 degrees Celsius probably, or somewhere below 100. So definitely you can see it has a very high melting point. Iron is a transition element, so it can be acting as a catalyst. All right. Anyways, iron has a higher density. We can also write that. So iron has high density compared to that of sodium metal. Nickel is extracted from nickel oxide by the reduction with carbon. Explain why carbon can be used to extract nickel from nickel oxide. So, why carbon? So basically the reason why we can use carbon is more reactive than nickel. Carbon is more reactive than nickel. All right. So carbon will displace nickel from nickel oxide. So carbon will displace nickel from nickel oxide. An equation for the reaction of the equation is NiO plus C, Ni plus CO. So we can see that the carbon is taking away the oxygen. The question says calculate the percentage atom economy for the reaction to produce nickel. Okay, guys, in order to calculate percentage economy, we need this particular formula. All right, we need mass of desired product divided by total mass of reactant. Okay, percentage, guys, I'm going to give you the formula even though the formula is not needed. However, I'm going to give you the formula: percentage atom economy. What does this refer to? Atom economy. Atom economy refers to the percentage of the desired atoms divided by the total amount of reactants. So in this case, nickel is the desired atom, so 59, and divided by NiO plus C. NiO is 75 and a carbon is 12. So it's basically 59 divided by 87. 59 divided by 87 into 100. 100. So this gives us 67.8%. So percentage atom economy is 67.8. Question number 10. Chemical reactions can produce electricity. Figure 13 shows a simple cell. Figure 13, electrode A, B, and electrolyte. Okay, which of these figure combinations would not give a zero reading on the voltmeter in figure 13? So let's see. In figure 13 means this is the figure to be used in conjunction with this particular answer. Okay, electrode A. All right, so the electrode A option is copper. Electrode B is also copper, and electrolyte solution is sodium chloride solution. Okay, all right. And then because both of them are copper, so definitely none of them will be able to take electron from one another because they have the same amount of reactivity. So this is a wrong answer. This is also a wrong answer. All right, copper and zinc. When we consider copper and zinc, there will be a potential difference. So voltmeter will give a reading. So copper and zinc with sodium chloride. We did not choose water because water is not a good conductor of electricity, whereas sodium chloride solution is a very good conductor of electricity. All right, next. Alkaline batteries are non-rechargeable. Why do alkaline batteries eventually stop working? Okay, so basically all batteries, those that are single-use batteries, they have reactants. Once those reactants are used up, the energy is used up. Okay, reactants are used up, so that's why they will eventually stop working, because they will not no longer have reactants. They are using the chemical potential energy to convert it into electrical energy. All right, so why alkaline batteries not to be recharged? So the reaction in this case, all right, we cannot recharge it because it is not reversible. The reaction is not reversible. Hydrogen fuel cells and rechargeable lithium-ion batteries can be used to power electric cars. Complete the balance equation for the overall reaction of the hydrogen fuel cell. So hydrogen plus oxygen, it produces water. So there will be two oxygens needed, uh, and four hydrogens, so 2H2. Question number 10.5, table 7 shows data about the different ways to power electric cars. Time taken to refuel, recharge in minutes. For hydrogen fuel cell, it only takes 5 minutes. Rechargeable lithium-ion battery, 30 minutes. Distance traveled before refueling or recharging in miles. All right, so it can hydrogen fuel cell can travel quite far, and rechargeable lithium-ion batteries can be also used quite far, but not as high as hydrogen fuel cell. Distance traveled per unit of energy in kilometer. So okay, that is 22 and 66. Cost of refueling 50 and 3. Minimum cost of car in pound 60,000, 18,000. Evaluate the use of hydrogen fuel cells compared with rechargeable lithium batteries to power electrical cars. Use table 7 and your known knowledge. So time for refueling a fuel cell is faster than recharging. Time for refueling is faster in fuel cell, all right, than recharging. All right, guys, moving to the next point. A fuel cell has greater range. We can see from here it has a 415. A fuel cell has greater range. A fuel cell has greater range. Now, reasons why lithium-ion battery could be judged as better option. So the disadvantage of lithium-ion batteries is that they can catch fire. Lithium-ion batteries can catch fire. And finally, we can write a con. All right, for lithium batteries, the lithium-ion batteries eventually cannot be recharged, so they have a finite life. And guys, finally, we can say cost of lithium-ion car. Cost of recharging is much less than refueling with hydrogen. You can also say cost of recharging is much. Cost of recharging is much less than refueling with hydrogen. Refueling with hydrogen. All right, guys. So we have done 5 points. 1 more point left. All right. So no emissions are produced. So no emissions are produced. All right, guys. That's all for today. Thank you for joining the class, and wish you best of luck for your exam. Guys, subscribe to the channel. All right, let the channel grow. I have currently moved to Dubai, and I'm here for like the last 7-8 months, and I did not upload any video. I wasn't able to. However, I do promise that a lot of videos will be uploaded in the channel at this point of time. I want to focus first on AQA question papers. All right, AQA, chemistry, biology, IGCSE is first, and then eventually leading to A-level question papers for chemistries and biologies. And also I'm going to focus on triple science. I'm going to give physics question paper solutions as well. Those are in my queue. All right, and eventually I will get them done. Guys, subscribe to the channel. And at this point of time, the channel doesn't have a way of receiving any donations or anything. But if you do, creating these contents requires quite some investment from my side, apart from the time. So if you do want to contribute, all right, I'll surely find out a way so that you can contribute a little bit. All right, you feel great from your part as well, being a contributor to the good work that is being done. All right, guys, see you in the next video. See you in the next lesson. All right, bye. Take care.